background about CloudyCluster. HPC modeling and simulation through parallel computation have provided for more safety in cars, bridges, buildings, roads, and almost anything that can be modeled or simulated. They've helped bring things to market faster. They've saved lives through genomics, bioinformatics, pharmaceuticals, and helped determine the basic building blocks of matter and antimatter for that matter, pun intended, building and test economic models and other social behaviors. To make the world a better place, HPC and parallel computation need to get in the hands of more people. The cloud and tools like CloudyCluster can help increase the use by orders of magnitude, breaking down barriers that we couldn't foresee. Amazon Web Services provides many microservices that are API-driven, that are the foundation for many major applications and companies today, including Netflix, Airbnb, Yelp, Expedia, Adobe, Pinterest, Zanga, Slack, Lyft, Foursquare, even Pfizer and Dow Jones and Bristol Myers Squibb all, leverage it for their infrastructure. When we're thinking specifically about high-performance computing in the cloud, we can also leverage many of these microservices. And as you can see, there's a vast number to choose from computation to storage to databases to networking components. And it's very powerful, but there's a lot to choose from, and you have to actually do some work to pull it together. And that's where CloudyCluster comes in. If you're building high-performance computing, and CloudyCluster does that, you can use many of these services that we've spoken about, and including EC2, Elastic Cloud Compute, S3 for object storage, Elastic File System for your NFS storage, DynamoDB for metadata storage, virtual private clouds, and Route 53 for DNS, and CloudFormation templates to help you spin everything up, and IAM access to manage the security of the whole environment. And inside the EC2 VPC and the IAM, you can see that you can have to deal with AMIs and volumes and spot instances, reserved instances, launch configurations, scaling groups, routing tables, internet gateways, elastic IPs. There's a lot to pull together, and that's where we hope that CloudyCluster can make it easier for people to kind of pull the right things together for the specific use case of high-performance computing. In addition to pulling the power of the AWS microservices together, CloudyCluster goes above and beyond that and actually mounts the file systems, sets up the scheduler, be it Torque or Slurm, does the software configuration, even does the MPI configuration, makes it all pulled together into a familiar looking high performance computing environment. We also provide easy access by WebSSH and Visual HPC. You can just flip a switch and be able to make VNC connections and do your Visual HPC work. The Metascheduler CCQ also is leveraged and allows you to launch jobs through it, and it dynamically spins up all the instances needed for the job, sends them off to the scheduler when the instances are ready, and when the job is complete, if there's no other jobs waiting around to be done on that instance type, it actually tears everything down so you don't have any added costs or extra fees. Trying to make this as efficient as possible. An overview of the components used to make up CloudyCluster, providing that fully operational HPC cluster that you can spin up in minutes. On the storage side, you have OrangeFS that runs across multiple instances and backed by EBS. You have S3 and EFS. OrangeFS providing that high throughput, high performance storage. S3 providing object storage, and EFS providing that NFS shared mount for multiple purposes. For the compute, you can select any instance type available from EC2, and you can drive those jobs to EC2 through auto-scaling groups through CCQ. So that way you can launch a job and it automatically scale, showing that power. On the scheduler, you have Torque and Maui or Slurm, and they're all supported through CCQ. And for HPC libraries, you have a vast variety of Boost, CUDA, Dakota, Docker, FLTK, GCC, Grib, GSL, Hadoop, HDF5, ImageMagick, Jasper, NetCDF, Python, RMPI, R, SciPy, SU2, and lots of things to really make it easier for you to just leverage with your code. And more complete HPC software such as Amber Tools and Atlas, Blast, CESM, GROMACS, NCL, NWChem, the three distributions that are popular for OpenFOAM and Quantum Espresso and even Wharf. So you could even also add your own software to this AMI and make a custom AMI. So you launch the AMI in the marketplace with a special CloudFormation template that you can reference in the documentation and install your application, save a new AMI, then you launch your CloudyCluster control instances and subsequent clusters from that new AMI that you made, and your software is already available. You also have the option just to install it in the shared EFS mount that you set up when you set up your cluster. All of this can be done from an easy to use web UI from your mobile tablet or desktop, and you also have the ability to spin up Globus endpoints, so you can transfer data in and out with a simple Globus UI, and it all ties into CloudyCluster very cleanly. We're looking to integrate iRODS and XDMod for the winter release to provide added data management capabilities and also HPC and job-based monitoring. So we're very excited. Now we'll give you a little more detailed overview of how CCQ works behind the scenes. So whether you're running Torque or Slurm for your scheduler that actually does the work behind, for the scheduling, CCQ front ends that scheduler. So you submit your job through CCQ using CCQ sub. You can check it with CCQ stat, and then it's usually generally done on the login instance. Then CCQ holds that job in DynamoDB, and then while it's holding there, it determines what type of instances are needed based on the hints that you put in, or actually inspecting the memory and other things that are needed as part of that job, spins up those instances if they're not already up and running and available for use, and then it actually sends those jobs to the scheduler, be it Torque or Slurm, when it's ready, and then the job is executed, results are written, and then when it's done, it checks to see if there's other jobs waiting for that instance type. If not, it hangs around before the billing hour completes and then terminates those instances so you're not paying for any excess cycles. So that's a fast and efficient way to use the resources optimally, and you could actually launch multiple jobs across different instance types all through CCQ, and it manages it for you. To go beyond just launching and creating clusters, which you can do without doing any of these other items, but you also have the ability to collaborate. You can invite other collaborators to CloudyCluster. They get an email, and when they respond, they get to finish out their account, and they have access to the same cluster. You can create collaborations inside of that, and with those collaborations, you can restrict access to schedulers or even do shared Google Drive folders, so you can have data storage and collections outside for more desktop purposes. We also provide OAuth and SHIB in common support for web authentication, so you can use federated logins in and out for the web. It gives you a secondary method. Also, you can use the local CloudyCluster authentication, which all the credentials are actually stored within your AWS account encrypted inside of DynamoDB. So it makes it easier, and HPC is more than just providing the computation. The collaboration and the people behind it is the real story. One of the questions that's always asked is about pricing, and CloudyCluster is priced based on demand as part of the AWS marketplace and is a small incremental charge in addition to the AWS EC2 pricing. You only pay for what you use, and there's no commitment. On the right, RHEL or RHEL pricing is displayed, and CentOS pricing is less. So to give you an example, a 5,000 core hour job could cost a little under $250, and you could run this job across as many nodes concurrently as your workload allows. And if your workload can support spot instances, this could even be as low as $60 to run this same 5,000 core hour job. This is all based on using C48XL compute instances, 36 core, 60 gigabytes of RAM. Using CloudyCluster 1.2 running on CentOS. The spot price plus CloudyCluster software at the time of recording was about 43 cents per instance hour. Or to give you an idea, that's just a little over a penny a core hour. So a very cost-effective solution. At the various conferences we attend, we always hand out these little cards. This is things are always larger than they appear, or this is larger than it appears in real life. But for $100 of AWS credit to give CloudyCluster a try. So you can either fill out the form outlined on the page right there, or the web URL, or you can send an email to promo@cloudycluster.com and just say you listened to the video and are interested in trying it out. And while supplies last, we're able to share credit with you thanks to the good folks at the AWS Marketplace.